Okay, similar shapes. Shapes are similar if they are the same shape, the angles are the same, and the ratios of corresponding sides are the same. So basically they look the same, perhaps they're turned around or flipped over. The angles in that shape are equal. So here I've got two right angles. I could be given those two sides, but instead they've got one marking on. And these two angles are equal where they've put two markings on. Okay, and then the ratios of sides are the same. So one is an enlargement of the other. So let's look at the ratios of sides. Okay, so we're looking for corresponding sides. So if I take this 12 centimetres here, that's between the right angle and the angle with two markings. So that's going to correspond to the side that is between the same here, the right angle and two markings. So they are what's called corresponding sides. So the ratio of those two sides is 12 to 30. Now where possible, simplify that ratio. So what times table are they both in? They're both in the 6 times table. 12 divided by 6 is 2 and 30 divided by 6 is 5. So these shapes are in the ratio 2 to 5. Let's just check that out with the other sides. So this side here that I'm going to underline is between the right angle and one marking. Right angle and one marking, it corresponds with that side. So 5 to 12.5. Is that the same as this ratio? It doesn't look it at the moment, so we've got to simplify that. Now it's a bit difficult to simplify when you've got decimals. So first of all, let's get rid of the decimal, let's multiply up. If we multiply them both by 10, I'll get rid of the decimal. So it's the same as the ratio 50 to 125. So now I can start simplifying that ratio. They're both in the 5 times table, so divide them both by 5. 50 divided by 5 is 10, and 125 divided by 5 is 25. And I can even simplify further by dividing by 5 again. How many 5s in 10? 2. How many 5s in 25? 5. So yes, they're in the same ratio, 2 to 5, 2 to 5. Let's have a look at the final one. Okay, between the two markings and one marking, two markings and one marking, 13 to 325. Now I could times by 10 here, 32.5. I could times by 10 here, but I'm going to end up with like 130 and 325. So actually on this one, I'm just going to make it a little bit easier by just multiplying by 2. And that'll get rid of the decimal. So that's 26 to double 32.5 is 65. What times table are they both in? They're both in the 13 times table. A bit tricky to notice, I know, but they are both in the 13 times table. 26 divided by 13 is 2. 65 divided by 13 is 5. So since all of the three sides are in the same ratio, 2 to 5, then those shapes are similar. So next one. We're going to have an example now where there's just some of the sides marked. We're looking for the ratio of corresponding sides in this shape. Okay, so which ones correspond? So, is it the 8 and the 16, the 8 and the 14, the 5 and the 16, the 5 and the 14? Let's look carefully. The 5 is between the one marking and two markings. One marking to two markings, there's nothing there. Okay, the 8 is between no markings and two markings. No markings and two markings. These are the corresponding sides. So imagine it spun around, it would look the same as that shape there. So these are in the ratio 8 to 14. Can we simplify that? They are both in the 2 times table. Divide them both by 2. It's 4 to 7. They're in the ratio 4 to 7. Okay? Right. I'm given this as a question, and I want the ratio of corresponding sides, okay? The ratios of these two similar shapes. You might look at that and say, well, what two similar shapes? You've got a triangle and a trapezium. Well, they can't be similar, they're not the same shape. But what you actually have is two triangles, two right angle triangles. That one there, and then the big one. So I've drawn them here. The big triangle and the little triangle. So this big triangle, that length there is 20 centimetres. I don't know that length and I don't know that. The small triangle, this length up here is 15 centimetres and the length across there is 9 centimetres. Now I know the angles are the same because they're both right angles. That's the same angle in both triangles. And this one here, well, these are two parallel lines and they're called corresponding angles. They are equal. So which pair of sides correspond, the 20 and the 9 or the 20 and the 15? Well, I've drawn them in the same direction, so you can see quite easily that it's the 20 and the 15. 20 to 15. Simplifying that, what times table are they both in? They're both in the 5 times table. How many 5s in 20? It's 4. How many 5s in 15? It's 3. Now I always also tend to write the ratio the same as we see the shapes. So it's in that order, the same as we see the shapes. Okay, now try the first exercise.